Welcome to the first segment of High School Geometry with Netz and Weichel. I'm Mrs. Netz.
And I'm Mrs. Weichel.
Today we are going to be doing 1.1 segments and lines. Our learning target for today is that we will understand how to think logically about solving problems with measurements and the relationship of points, lines, segments, and planes. Why we are doing this? When thinking logically, many different problems in math and in life can be solved more easily. How you will know you have mastered it is when you can explain how to solve problems involving points, lines, line segments, and planes. Geometry. Geometry stems from the Greek word for measurement and earth. It is a study of the size, shape, and position and 2 and 3-dimensional figures. Based on historical data, originated because people had to measure land.
Euclid, who is considered the father of geometry, basically wrote some famous books that we all still use today. Basically, everything you're going to be learning in this class stems from something that he found or wrote about.
So we call this Euclidean geometry. Euclid lived around 325 to 270 BC.
All right, our first vocabulary word for this chapter is the word point. A point is a specific location with no size. That's a very important thing to understand. No matter how big, small you draw the little dot you're drawing, it really represents no size. It's just a location that you're referring to.
So if you are using a copy of our guided notes, you have a table, and in your first column, you're going to go ahead and write the term and definition. So you'll write point, and then you'll write under the word point a specific location.
In the middle box, or the middle row of your table, column of your table, it's labeled example. This is where you're actually going to draw a picture of what we're talking about. So in this case, you're going to draw a point, which is denoted by a little dot, and then we're going to use the letter P for point. In the last column, how to name, this is where you're going to write how you would reference or name the object that we're referring to. When you are naming a point, you will always just use one capital letter for that specific letter. In this case, we are calling this point P, so I would name it with point P.
Always using the capital letter.
Never lowercase.
That's the most important.
So all you guys that don't follow traditional writing rules with capital and lowercase letters, points are always capital.
Now it's important. All right, so our next word, line, and in your first box, you're going to go ahead and write line, which is a straight path that goes on forever in 2 directions infinitely. So we have for you an example here, a line, and you'll see the arrow on both ends.
Because we can't draw forever, we can't draw infinite, we show infinite with arrows. So anytime you're talking about the word infinite or going on forever and ever, you will show that with arrows.
Okay, so let's talk about a couple of ways to name this line. So we're going to name this line, it looks like, in a total of 3 different ways. Our first possibility is line JK. So we'll write JK, and then we'll use our geometric symbol for line over the top of it.
It's very important to know that to name a line, to create a line, you need just 2 points. You could have 10, you could have an infinite number of points, you could have 20, you could have any number, but you need 2 to name a line.
Any 2 on the line. So in the event that this line had another point on it, you could use any of the points. You just need 2 of them to name the line. So another way to name this line would be to call it line KJ. And again, using our symbol for line right above it. The third possible way to name this line, if you'll notice, we have a lowercase q written off on the side. Oftentimes you will see this, and when you see this, they are letting you know that this is line Q. This would be the one and only time that you would name a line with only 1 letter and have it be lowercase. Please note that when naming a line using 2 letters, they will be uppercase because they are referring to points that are on that line.
Your third and final vocabulary word in this particular table is the word plane. A plane is a flat surface that extends infinitely. Again, we can't really show that idea of infinite. Basically, anything on your paper is on the same plane. So right here, you can see I have this sort of shaded shape right here. That right there would be considered a plane. Everything that is actually on my screen would be on the same plane. If I were to put my pencil down on my paper, and it's sticking straight up, that would be on a different plane. As soon as you change direction in which you're going and you go to third dimension or anything, that's going to change the plane in which you are on.
Another example to help you understand planes, if you were, for example, to have two buildings that were next door to each other, the second floor of one and the second floor of another are both on the same plane. You have to imagine that they would be connected by this imaginary horizontal floor that is not there, hence imaginary. All right, so the way we name it, there's a couple of different ways, or actually only one way we can name it, my apologies, and we're going to name it using the lowercase letter that we have found on it. And this lowercase letter in this case is D.
You can actually, you were right, you can do it another way.
By using points
If you
on that
have
plane.
3 points, they will make one plane always. So just like a line, if you have 2 points, you make one line. If you have 3 points, you basically just list those 3 points together without any separation, and you're referring to the plane those 3 points are on.
So one of the things that you all may want to make a quick note of, because you are going to see this in your practice on Khan Academy, is that any 2 points you can make a line. Any 3 points you can use to make a plane.
So right here you can see I have a single line right here. You would name that line either line DO, line OG, line DG. Those are all 3 examples of the same line, but because they are 3 points on the same line, we can say that those 3 points are collinear. 3 points make a plane, so once you go into the 4th point, if they are all on the same plane, we can say they are coplanar.
Okay, so let's go on and talk about undefined terms. Undefined terms is a term or a point, line, or a plane that are not definable. So in this case, a point is not measurable. A line, because it goes on forever, also not measurable. And a plane also goes on forever, is not measurable.
So we're talking about 3 objects that you cannot measure.
So undefined is something that cannot be measured. So for example, lines and planes go on forever. Points are a location, they're not measurable.
There's no size to them.
Or if you remember in Algebra 1, you learned about dividing by 0 is undefined because again, it cannot be measured.
Okay. All right, go ahead and turn the page, or if at any time you can pause and go back, please do so at this time.
All right, so let's talk about an intersection. An intersection is something in common between 2 or more things. So in common, it's shared. So these 2 things share something. So when you talk about things sharing something, it's where they intersect or come together. Okay, so the very first one we're going to talk about is the intersection of 2 lines.
2 lines, because they are extending infinitely in opposite directions. If they were to ever cross each other, they are only going to cross at one single place. And that one single place is a location, which would be a point. In the example I have on the screen, and I did give you space if you're using guided notes to draw this below, we are intersecting lines M and N at point X. So lines intersect at one single point.
Okay, so it's very important to remember that if you look at where they cross, they are crossing at a point.
They are never going to cross more than once again because lines extend infinitely in opposite directions. So if it were to curve back around, we would no longer have a line.
Okay, then we have the intersection of planes. So imagine 2 pieces of paper intersecting. So, or
Or a
look,
wall.
or
Look at
look
the
at a
room you're
wall.
in right now. Look at the floor and look at the wall in front of you. Where those two planes are intersecting is probably the baseboard.
Yeah,
Um, in that case, it is finite. It does end at the corners of the room, but in the world of geometry, remember these are invisible planes that extend infinitely. So they're actually intersecting at a line.
that's very, very, very important that you understand that plane A and plane B intersect at line L. There's our lowercase letter again. So they intersect at a line. Two planes, if you'll make a side note, two planes do not ever intersect at a point.
And again, if you think about it in your house, if you're looking at the floor and the wall in front of you, they are meeting. If you look at the corner, there are two corners where your walls are in the floor are meeting up. Those are 2 points. Remember, 2 points make a line. So they're not just intersecting at one single place. It's multiple places along that baseboard.
Okay, so on that note, let's get into a couple of more definitions. Please make sure that you have highlighted in your notes or you have written down intersection, intersection of lines, and intersection of planes, because you will need to make sure that you understand those definitions. So we have a table again, and our very first term definition is going to be parallel lines. Parallel lines are lines that are in the same plane and they never intersect. So these are two lines that you basically could, if you think about it, if they were boards, you could take a piece of paper and lay it on top and they would have one plane. So they are always on the same plane together and they are always the same distance apart.
So technically speaking, if you draw two lines on your paper, if you're not trying to make it third dimension, they should be parallel. If you're making them go, if you're keeping them equal distance apart.
A couple of things that are important is it's always important to mark parallel lines with a symbol to show that they are parallel.
Right now, while I have drawn these to be parallel, and on your paper I've drawn them to be parallel, you are never going to assume they are parallel unless you are told they are parallel. The way we show that on the picture is by adding a pair of angles on the line. Sometimes you'll see them as
Sometimes you'll see them
in.
colored in, filled in, and then sometimes you'll see them just as
just like these
little arrow markers. Okay.
So this is my way of showing on the picture that we have a pair of parallel lines. To write it down, to reference it, we can say line L, and then you're going to put the symbol for parallel, which is a pair of parallel lines that are kind of, typically they're going at a slight diagonal, sometimes they're vertical, and then you'll list the other line, which would be B.
The easiest way to help you remember this is if you look at the actual word parallel, you will see in the word parallel the symbol for parallel lines.
And this would be read, line A is parallel to line B.
All right, let's move on. So now we're going to talk about what we call skew lines. Skew lines are lines that are not parallel and they are not in the same plane. Up until now, you have always thought that lines that never intersect are always parallel. We're going to go ahead and raise that level of knowledge to lines that never intersect could either be parallel or skew.
Now we're bringing in another dimension. We're bringing in multiple planes. So even though this is flat on your paper, we're trying to show depth right here. Whoops, sorry about that. This is actually a cube. And we're showing that there are all these different sides to this cube. So this is technically not the same, the front of it is technically not the same plane as the back of it. The left side, the right side, these are all different planes.
So what we are looking for here is lines that are not, or lines that are, sorry, skew to line A. So what we are not looking for are lines that are parallel. We don't want any lines that are parallel, and we don't want any lines that
will intersect line A.
That will intersect. So lines that would be skew, if you look at the bottom of the cube, they're going in the opposite direction of line A, but they're on a different plane. They're on the bottom, so they are skew.
So if you look, line B is going front to back. line A is going left to right, so they are not going in the same direction, and one is on the top, one is on the bottom, so they're never going to meet up. They're never going to have anything in common.
Okay, and then we have our two lines on the back. If you look, lines D and E. Lines D and E go vertically on the back. Line A goes horizontally on the front. There's nothing in common about either of these. So again, A is horizontal on the front. D and E are vertical on the back. So because they have nothing in common, we call them skew.
And there's no special symbol for skew, so we just kind of have to write it out. So B, C, D, and E are skewed to line A is how you would write that.
All right, let's go on.
And the last one on this table, perpendicular lines.
So a couple of things. So number one, you're going to go ahead and write perpendicular lines, and then you're going to go ahead and give your definition. Lines that intersect at a right angle. A right angle is always going to be 90 degrees.
That's really important and somehow gets missed by a lot of students. You can have intersecting lines. Perpendicular lines are intersecting, but they specifically intersect. We're going to go ahead and add in that we have a little right angle mark right there showing that line A is perpendicular to B.
So if that little right angle is not there, please do not ever assume that those two lines are right. They could be at 89 degrees, which would look very, very similar to 90 degrees. So you cannot make the assumption they are perpendicular unless the symbol is there.
And then to reference it, we would write line A is perpendicular to line B, and the symbol for perpendicular is an upside down T. That's going to show that you have right angles where the lines intersect.
Okay, so now we're going to move on to rays and segments. Rays. A ray is a part of a line that goes on infinitely only in one direction. The important thing for you to remember here is a ray will have what we call one end point, meaning it ends, it stops. So point T is an end point. Another important thing is when you are naming a ray, order does matter, and the symbol will matter as well. So we're going to use the symbol for ray, which looks like a ray, but the ray symbol is always going to point to the right, which means wherever your end point is has to be the first letter. Even if this image was flipped and this was ray WT, then you would have to show it was ray WT. So in this example, we're going to go ahead and draw our ray going the opposite direction.
I'm actually going to bring in another vocabulary word.
Oh, nice.
Right here, we'll do C-A-T, because Mrs. Weichel likes cats.
Very nice.
In case you want to know something about your teacher.
Yes.
Right here, I actually have a pair of opposite rays.
Oh, yes, we do.
Opposite rays actually form a line because you have two rays going in opposite direction. If I was going to name these opposite rays, the first one is going to be named the same way as I named ray TW. It's going to be endpoint A going towards T, like that. The one that is kind of confusing for some students is the opposite ray to this, which we would have to name, even though it's pointing to the left, it would be named A is the endpoint going towards C. So that is actually named ray AC. So there's a pair of opposite rays. All right, and our last vocabulary word for this particular table is going to be a segment.
And actually, we could steal your cat from the previous.
We could.
Because there are multiple segments on your line cat. So let's talk about segment. A segment is a part of a line, and the most important thing for you to remember here is it has two end points because it ends. A segment, remember, is a part of a line.
It's finite, meaning it starts and finishes.
Now, with a segment, Order doesn't matter in how you name it, just as long as you have 2 points.
And you have to use the end points in this case because it's not extending infinitely. So in this case, even if I had a point right here, if I wanted to use the entire picture, it would have to be E, starting at E, ending at Z. So we have E, Z, with a picture of a segment over the top. Now, segment ZE is the same one. It does not matter which way you name it. You're talking about the same physical space, but you have to make sure you're using the endpoints.
Absolutely. Okay, so let's move on and do some math. A little bit.
The last thing we're going to talk about is the segment addition postulate.
This is the easiest thing ever. If you think about it, the segment addition postulate, all it is saying is if you take a part of a line and add the other part of a segment, sorry, not line, that when you add them together, they equal the entire segment.
You're always going to add the two smaller ones together. So in this case, we have these two smaller ones. So I'm going to go ahead and write this. We have segment AB, and that's being added to segment BC.
And when you do that, it equals the entire line, or the entire segment, excuse me, and that entire segment is AC.
Right there. So we would finish that by saying, when I add these two together, you get segment AC.
So a couple of ideas to help you get this one is basically if you take the part and you add another part, you get the whole. Another example to help you out a little bit, if we say that AB is 3 and we say that BC is 6, we know that the entire line, or sorry, segment,
the entire segment
has to be 9.
Exactly.
Okay, so
we're just about done. We just have some basic vocabulary words we want to talk about. The first is bisect. Bisect means to divide into 2 equal parts. I went ahead and drew a picture of a segment being bisected right here. We had this segment and then I cut it in half right here. I'm showing that these are 2 equal parts by these markings.
Those are congruency markers showing that they are congruent.
The next vocabulary word kind of falls in line with this. If you were to bisect a segment, the point that you're creating right here, we would call the midpoint. It is the middle point of a segment. So right here was where my bisector was. That point we would call a midpoint.
So think of bisect as bi, meaning 2, and sect means section. So it's 2 sections. Midpoint, mid, meaning middle, and point is a point. So it's a middle point.
Exactly. Last thing, just if you're given a midpoint, you can always choose, or you need to look at what you're given when solving a problem, like on the practice assignment that's going along with this. If you're given this picture, you can see that B is making 2 smaller segments on segment AC, but it is specifically in the middle. So remember, you can use segment addition, or you can use the fact that you have a bisector. So there's 2 possible equations that can be made from that. One more thing.
This one's actually kind of fun, and you're going to see this on Khan Academy quite a bit. You'll be given a plane, and then on that plane you will have this line that is going through the plane. So the line that goes through the plane, if you imagine, you'll be able to see the line at the top, and you'll be able to see the line coming out of the bottom, but you will not be able to see the line that is somewhat hidden by the piece of paper, so to speak. So it's going to be dotted, or maybe it'll even just look like we have right now where you just can't see it, but it goes through. Okay.
So picture a piece of paper and then you're stabbing your pencil through it. That's kind of what we're describing right now.
So, and then what they're going to do is they're going to give you various points. Some of the points will be on the line, some of the points will be on the plane. This is where you need to apply some of the things that you just learned. Number 1, any 2 points are always going to be collinear.
Because between 2 points, there is always exactly one line.
So for example, A and C are collinear.
Because I can make a line through A and C. Just because it's not drawn there doesn't mean that there isn't a line that is in existence right there.
Okay, and the same goes for BC. Now, any 3 points, regardless of where they are at or where they have been drawn, will always be coplanar.
So even though we have a plane here and we have a second plane going here, I could make, a plane. I'm going to draw a triangle here. That would be a plane.
And that plane may not be the plane that is drawn there. However, please keep in mind that any 3 points will always make a plane.
I believe that that is the conclusion of our lesson. We always ask you guys to self-reflect when we are all done. So we want to know how you rate yourself. Red, meaning you're completely lost. Yellow, you're kind of lost, but you kind of get it. Maybe with some practice or some clarifying questions, you'll get it. And then lastly, green, you're ready to take the test. You got it. How do you feel about lines and segments? How do you feel about the segment addition postulate, where you add 2 smaller pieces and make 1 total? How do you feel about the midpoint definition? Do you feel like you get what a midpoint is and what bisecting means? If you feel good about all those things and you're ready to go on to the practice for this evening, you're going to be completing 1.1 practice and your Khan Academy assignment that we have assigned you. If you guys have questions, please make sure you message us on Remind, or you can email us at our email addresses that I've typed on here for you guys.
Hey, Mrs. Weichel.
Hey, what, Miss Nets?
What shape is usually waiting for you at Starbucks?
What?
A line.
Thank
See
you
you in
for
our next
joining
segment.
us.